Good morning, class 8 students of chemistry. Today I am coming to the concluding part of the revision of the 5th chapter of Language of Chemistry. And children, in this chapter, we see that in video 5, the last one, we learned and revised about writing a balanced chemical equation. We learned about the law of conservation of mass, which applies to the balancing of the equation. Then we revised many methods of balancing chemical equations in the last video. But the easiest we used was hit and trial method. Then children, we revised the balancing of chemical equations with various examples. We also did many examples of balancing of chemical equations, children, in the assignment number 5 that I gave you yesterday. Now today let us see yet another example of balancing a chemical equation. And we see, children, that in this particular equation, C6H12 plus O6, we see what are the products formed from these reactants C6H12 plus O2. The products formed are CO2, carbon dioxide and water. In step 1, we will see which are the atoms which are not balanced. So here we see C6 and here we see C is 1. Here we see H12, here we see H only 2. Here we see oxygen 2, here we see oxygen is 3. So let us balance these atoms one by one, children. And we see that the first step in this is to balance the carbon. There are 6 carbons on the left hand side. Do you see here? There are 6 carbons on the left hand side. So we have to balance it by putting before CO2 6, the figure 6 or the coefficient 6 or the right hand side. So when we put the figure 6 on the right hand side before CO2, now both sides we have got carbon 6 and here also carbon 6. Then let us go to step 2. Then we can balance hydrogen here. There are 12 hydrogen on the left. Do you see here? There are 12 hydrogen on the left, and so we put a figure 6 before H2O, so that this here also the hydrogen becomes 6 2s are 12. So on the left hand side we had 12 hydrogen, and on the right hand side also 6 2s are 12. We have 12 hydrogen. Then children, let us come to step 3. Then we can balance oxygen. There are 18 oxygen on the right. We can see that there are 18 oxygens on the right, which is 6 to the 12 and plus 6 oxygen. 12 plus 6 is 18. So we see that there are 18 oxygen on the right, and so we put 9 before O2, so that here also on the left hand side we will have 18 oxygen. So let us do that, children. Here we see in this particular reaction, on the left hand side now we have 18 oxygen, 9 2s are 18, and here also we have 6 2s are 12, and we have 6 1s are 6 oxygen here. So 6 plus 12 makes 18 oxygen on the right hand side also. Thus the balanced equation now becomes C6H12 plus 9O2, which gives the product 6 carbon dioxide plus 6 H2O. There are many limitations or drawbacks of a chemical equation. The chemical equation does not indicate many things, as we can see here. The physical states of the reactants and the products, they are not shown here. Then about the reversibility of the reaction, we do not know whether this reaction is a reversible reaction or not. Then we see the conditions necessary for the reaction to occur. So what are the conditions under which this reaction is occurring? Then we see the concentration of the solutions of the reactants and the products, whether they are concentrated solutions or there are dilute acids, we do not know. Then the fifth drawback we see, or limitation we see in a chemical equation, is that the heat changes during chemical equation. We do not know whether the heat is evolved or the heat is absorbed. Then in the sixth one, we have the limitation that whether any precipitate is formed or not. Then we see whether any gas is evolved or not. Then we see the time taken by the reaction for completion. How much is the time that has been taken by the reaction? We do not know. The rate at which the reaction takes place. What is the speed of the reaction, whether it was a slow or it was a fast reaction. Then the 10th limitation we see is the extent up to which the reaction takes place, whether the reaction has taken place completely or partially. Then we see the in 11th point we see the mechanism of the reaction. What is the mechanism of the reaction? Whether any catalyst is used or not, or a promoter has been used or not. So all these limitations or drawbacks, 12 drawbacks we saw in this chemical equation. Now, how we can remove these drawbacks, children? Let us revise once again. Some of the drawbacks of chemical equation can be removed as follows. The physical states of the reactants and products can be indicated by using the symbol S. As we can see here, zinc is shown with the symbol S. S is for solids. And also L is the symbol for liquids that can be shown here in the reaction. G is for gases. So we see here hydrogen is a gas, so we have depicted it with G for gases, and AQ for an aqueous solution. So for HCl we have put AQ to show that it is an aqueous solution, and also zinc chloride, which is a product formed in this equation. This is also an aqueous solution. Then children, let us see the conditions necessary for the reaction to occur are represented along the arrows between the reactants and the products. The conditions necessary. For example, here the condition is heat. When heat is involved in reacting iron with sulfur, then we get iron sulfide. Likewise, we see another removal of drawback here can be the concentrations of the solutions of reactants can be indicated by writing DIL for dilute and CONC or concentrated for concentrated solutions, etc. For example, here you see children, copper plus 2H2SO4, which is concentrated acid, and here the condition is heat. Heat is involved in doing this reaction of reacting copper with concentrated sulfuric acid, and we get copper sulfate, which is aqueous solution. We get SO2, which is a gas, has been indicated by G, and we get water, which is a liquid, indicated by L. Then we see the heat changes during a reaction are indicated by writing the kilojoules, which are either coming out or the kilojoules which are being absorbed, along with the products for exothermic and endothermic reactions respectively, or actual value of heat energy can be written. For example, in 2H2 we see gas is reacted with another gas, oxygen, and this gives us water, which is liquid, and Here the amount of heat that is coming out is 572 kilojoules. Now let us see another reaction here. In this reaction we see carbon reacts with water, and this gives us carbon monoxide and hydrogen gas, and we see here 131 kilojoules of heat energy is being absorbed. Then we see the evolution of a gas can be indicated also by putting an arrow pointing upwards. If we put an arrow which is pointing upwards, we can show the coming out of a gas. So in this particular equation, we see zinc reacts with dilute sulfuric acid to give zinc sulfate and hydrogen gas, and we have shown the upward facing arrow here to show that gas is coming out. Then here, children, in the sixth point, we can remove the drawback by another way. The formation of a precipitate is indicated by putting an arrow pointing downwards, or by writing the word PPT below the formula of the product. Like in this example, silver nitrate reacts with sodium chloride to give AgCl, which is a precipitate. Also we can indicate by downward facing arrow. PPT we have written in brackets, children. And likewise in sodium nitrate we see that this is an aqueous solution. Then we see in case of reversible reaction, we can use double-headed arrows shown here like this, and these are used between the reactants and the products. N2 plus O2, this gives us nitrogen oxide, and we see this is a reversible reaction, and the condition here is heat that is used 3000 degree Celsius. This is a reversible reaction shown by the double-headed arrows. Then another way of removing the drawbacks of a chemical reaction is the rate of reaction can be indicated by writing slow or fast along with the products. For example, let us see here 2NO plus O2 gives NO2. This is a fast reaction, so we have written in brackets fast. Likewise, in this particular example, we have carbon monoxide, which is a gas. It reacts with oxygen, which is another gas, to give carbon dioxide, another gas. But here we see that it is a slow reaction because in the brackets we have mentioned slow. So children, thus we have concluded with the revision of the 5th chapter of Language of Chemistry. So we will start with the revision of another chapter of first terminal examination tomorrow, children. So till today we finish this video here. Have a good day. Thank you.